Welcome back. Problem 1-64. This problem is taken from chapter number 1, Stress, and book name is Mechanics of Material by R.C. Hibbeler. So statement is a vertical force of P 1500 is applied to the bell crank. Determine the average normal stress developed in 10 mm diameter of rod CD and average shear stress developed in 6 mm diameter pin B that is subjected to double shear. So you can see this is the bell crank which is applied a load of 1500 Newton, and this is the rod CD which is used to support this bell crank. And there is a pin support at point B. So this pin having diameter of 6 mm, while this rod CD has diameter of 10 mm. So you have to find the average normal stress in this CD, and there is a pin. You have to find the shearing stress in that pin. So let's start with the solution. So if you take the bell crank free body diagram FBD. So what if we remove this pin support at point B? So you will be having a vertical reaction force which is represented as By, and there will be a horizontal reaction force which is represented as Bx. Always try to draw it separately for saving time and drawing it over here. And the rod CD exert a force FCD in this direction. You can see that this force is downward, causing the rod causing it to move itward. As a result, the rod exert force in this direction, which is FCD. So we'll find this FCD, Bx, and By using equation of equilibrium. So first equation of equilibrium is that sum of all moments about point B is equal to 0, and taking the counterclockwise moment as positive. So about point B, first moment will be P into perpendicular distance is 450, and this is producing clockwise, so it will be negative. We will convert this 450 millimeter into meter, which is 0.45 meter. So P into 0.45, and I will also put the value of P which is given as 1500. So 1500 into 0.45, and you can see that this FC is producing counterclockwise movement because perpendicular distance is this one, and this is the force. About point B it is producing counterclockwise movement, so it will be positive. So how we will get this vertical distance? So you can see if I draw perpendicular line, so this is 45, so this will be also 45, and this distance will be equal to if you take sine of 45 degree. Okay, let me explain it over here. You can see you have one, this FCD is 300 millimeters. So you can see you have one portion is this one, another one is this one. This is the perpendicular distance. So if you take sine of 45 degree, so it will be equal to, let this is y, it will be y divided by CB, which is 300 millimeter. So 300 millimeter, so y will be equal to, this is in millimeter, so y will be equal to 300 into sine of 45 degree, and the unit will be millimeter. So if you want to convert it into meter, it will be 0.30 sine of 45 degree. Now you can see this FCD and perpendicular distance is this one here. This is the perpendicular distance, and it is producing counterclockwise movement, so it will be positive. So I can write plus FCD into 0.30 sine of 45 degree, and it will convert, the unit will be in meter. Okay, now their sum must be equal to 0. So from here you will get FCD is equal to 1500 multiplied by 0.45 divided by 0.30 sine of 45 degree, and that will give you 3181.98 Newton. Now we'll find Bx and By using another equation of equilibrium, that sum of all forces along x direction must be equal to 0, and force in this direction is taken as positive. Now you can see that we have one force Bx is in this direction, which is positive, and FCD is in opposite direction. Their sum must be equal to 0. So I can write Bx minus FCD is equal to 0. So Bx should be equal to FCD for equilibrium, and FCD is 3181.98 Newton. The last thing is that we can find the third force, which is vertical By, and it can be found by using this equation of equilibrium. So By minus this P, which is 1500, is equal to 0. So from here you will get By is equal to 1500 Newton. Now you have all three forces. So what we will go is that force in this rod is this one, FCD 3181. Clear? So what we are going to find the average normal stress in rod CD, which is equal to force in rod CD divided by area of CD. So force in rod CD is 3181.98. Diameter of rod CD is given as 10 millimeter, which is equal to 0.01 meter. Clear? So we will use this, and diameter of it is equal to pi by 4 d square, and d is 0.01 square. So it is 3181.98, and diameter will comes out to be 78.54 into 10 to the power minus 6. Okay. Now if you further simply calculate it, so you will get average normal stress in rod CD comes out to be 40.5 into 10 to the power 6 Pascal, and you will get average normal stress in rod CD will be equal to 40.5 megapascal, which is the answer of our first part. Now we'll move towards second part, and in second part we have been asked to find the average shear stress in pin B. Okay. You can see here that this is By, and this is By, and this is Bx. So if you draw it by using head to tail rule, clear? So there will be a resultant force which will be B, and that will act on this pin B, clear? So how we can find this? Because you can see one is vertical component By. Let me draw it. This is the B, this is By, and this is Bx, clear? So by using Pythagoras theorem, B will be equal to Bx square plus By square under the root. So we will calculate this B by using Pythagoras theorem. So B is equal to Bx square plus By square under the root. Put the value Bx is 3181.98 square plus By is 1500 square under the root. So you will get this B will be equal to 3517.81 Newton. Now you have this B. So you can see if I draw this pin like this, if I want to draw the pin like this at B, so this B is acting over here, and it is given that it is double shear because there are two supports, so VB and VB. So this shear force will be equal to, this B will be equal to 2V, double shear. So shear force will be equal to B by 2, and 3517.81 divided by 2 will give you the shear force VB on the pin. and this shear force comes out to be 17,1758.91 Newton. Now you have shear force. We know that every shearing stress is equal to shear force divided by shear area, which is area of this pin B. So put the value 1758.91. The diameter of this pin is given as 6 millimeter, which is equal to 0.006 meter. So what will be the diameter? So diameter is pi by 4 d square. D is 0.006 square. And when you calculate it, it will give you 62.2 into 10 to the power 6 Pascal. And in terms of megapascal, it will be 62.2 megapascal. And that is the answer of our second part. And this was all about this problem 1-64. I hope you have enjoyed this video and you have learned from it. Those who are new to my channel, then subscribe it and don't forget to press the bell icon so that you can get notification about my latest videos. If you have any question, you can ask me in comment section. I will suggest you to try this problem by your own, and if you feel any difficulty, you can ask. Thank you. Welcome back. Problem 1-76. This problem is taken from chapter number 1, stress, and the book name is Mechanics of Material by R.C. Hibbeler. So statement is the hangers support the joist uniformly so that it assume the 4 nails on each hanger carries an equal portion of the load. Determine the smallest diameter of nails at A and B if allowable stress for the nail is 4 kSi. So shearing stress is 4 kSi. The hanger only supports the vertical load. So you can see this is the joist and these are hangers at A and B. Clear? And in this hanger we have 4 nails on each hanger, 2 on this side and 2 on other sides. Similarly here there are 2 nails on this side and 2 on other side. And this hangers only supports vertical reaction. Clear? And the loading on this joist is shown over here. So you have to determine the diameter of these nails and these nails, and the shearing stress is given as 4 kSi. So let's start with the solution. So what will be the first step is if you remove this support, hanger support at A, so it will be replaced by a vertical reaction which is represented as Fa, and if you remove this hanger at B, so there will be a reaction force by this hanger on this joist will be Fb, and we'll find this Fa and Fb by using equation of equilibrium. But before that, if you can see that if this load is like this here, so what we are going to do is that we will convert this load. This is a mixed loading, so we'll convert it into distributed load with a triangular load. So this distributed load will have magnitude 30 pounds per feet, while this magnitude of triangular load will be 40 minus 30 will be equal to 10 pounds per feet. So let me divide it. So I will take a horizontal line. So you can see this will be distributed load, and the magnitude here will be equal to 40 minus 30, which will be 10 pounds per feet. Okay, so when you convert this distributed load into a point load, so it will be equal to, this will be a point load, it will be equal to 30 into the length over which it acts. So 30 into 18 will be equal to 540 pounds. And when you convert this triangular load into a point load, so what we are going to is that it will be converted into point load since it is triangular, so it will be equal to 1/2 into the magnitude, which is 10, and the length over which it acts is 18 feet. So I will write 18, and that will give you 90 pounds. It's 90 pounds. Now the distributed load will act at a half of the distance of full length, which full length is 18, so 18 divided by 2 will be equal to 9 feet. And this triangular load will, when converted into point load, so it will act at a distance of L by 3 from this end B. So L is 18, so 18 by 3 will be equal to 6 feet. So 6 feet from the point B. So I will write it, this distance is 6 feet. Okay, and the remaining distance is 3 feet. Now we'll apply the equation of equilibrium. So what will be the equation of equilibrium? So first equation of equilibrium is that sum of all moment about point A is equal to 0 and taking the counterclockwise moment as positive. So about point A, the first moment will be this load, which is 540 and perpendicular distance is 9, and this will produce clockwise moment, so it will be negative. The second moment will be this load, which is 90 pounds and perpendicular distance is 12, and this is also negative because it is clockwise. The third moment will be this FB into perpendicular distance is 18, and it is producing counterclockwise moment, so it will be positive. And the sum of all moment about point A must be equal to 0. So I will write 540 multiplied by 9, this is clockwise, minus 90 into 12 plus FB into 18 is equal to 0. So when you calculate it, you will get this 18 FB will be equal to 540 multiplied by 9 plus 90 into 12. So FB will be equal to 540 multiplied by 9 plus 90 into 12 divided by 18, and you will get this force, vertical force at point B will be equal to 330 pounds. Now you have this FB, you can find this FA by using equation of equilibrium. That sum of all forces along y direction must be equal to 0 and upward force is taken as positive. So you can see FA plus FB minus 540 and minus 90 is equal to 0. So I will write FA plus FB, which is 330 minus 540 minus 90 is equal to 0. So FA plus 330 minus 630 will be equal to 0. So FA minus 300 is equal to 0. So from here you will get this FA will be equal to 300 pounds. Vertical force at point B is equal to 330 pounds there, and at A it is 300 pounds. And you can see this vertical force is applied reaction force of this hanger on this joist. As a result, joist will also, this is supporting this joist, so definitely this force will cause shearing stress in these nails. There are 4 nails at A there. So what we will do is that we will calculate the diameter. So I will write for nails at A, we know that allowable shearing stress is equal to shear force divided by vertical shear force divided by area of nails. So this is for single nail. Okay. Or you can also write it like this, that total area of shear force divided by total area, because this shear force is, these 4 nails are taking this shear force. Clear? So total area will be equal to FA divided by 4 times area of single nail is pi by 4 dA square. Clear? And what we will do is that we have been given as, we are going to find dA. So dA square will be equal to FA divided by pi into T allowable. So you can put the value 300 divided by pi multiplied by allowable shearing stress is 4 ksi. So 4 into 10 raised to power 3 ksi will be equal to dA square. So from here you will get dA will be equal to 300 divided by pi multiplied by 4 into 10 raised to power 3 under the root, and you will get diameter of nail at A will be equal to 0.155 inch. So this is the diameter of nail at A. Similarly, you can find for nails at B. Nails at B, allowable shearing stress is equal to vertical shearing force at B divided by area of nails B. Since there are 4 nails, so I will write 4 multiplied by area of one nail is 4 pi by 4 dB square. And same you will get this dB square will be equal to FB divided by pi into the allowable. So you can just put the value of FB is 330 pounds. You can see this is 330 pounds divided by pi multiplied by allowable is 4 ksi. So 4 into 10 to the power 3, which is dB square. And from here you will get dB will be equal to under the root 330 divided by pi multiplied by 4 into 10 to the power 3. And you will get, when you solve this, you will get diameter of nails at B will be equal to 0.162 inch. So these are diameter of nails at A, and this is the diameter of nails at B, and which is the answer of this question. And that was all about this problem 1-76. I hope you have enjoyed this video and you have learned from it. Those who are new to my channel, then subscribe it and hit the bell icon so that you can get notification about my latest videos. Please share these videos with your communities and help me in growing further. And if you have any question, you can ask me in comment section. Thank you for watching. Welcome back. In this video, we are going to solve problem 1-85 that is taken from chapter number 1, stress, and book name is Mechanics of Materials by R.C. Hibbeler. So statement is the beam is made from southern pine and is supported by base plates resisting on the brickwork. If the allowable bearing stress for the materials are for pine, it is 2.81 ksi, and for brick allowable bearing stress is 6.70 ksi. Determine the required length of the base plates at A and B to the nearest 1/4 inch in order to support the load shown. The plates are 3 inch wide. So you can see this is the beam here that is made up of southern pipe, and there is uniformly distributed load from one end till the over the whole length, that is 200 pound per feet, and there is a 6 skip load at a length of 5 feet from this point A, and there is a base plate between this beam and this bricks there, so you have to find the length of this base plate. So let's start with the solution. So first step is that if you remove this support at the brick, so there will be a reaction force. Let this reaction force is RA, and if you remove this bricks, so there will be a reaction force offered by this brick on this beam or base plate, which will be RB. Okay, now this 6 skip is equal to 6,000 pound. 6 skip is 6,000 pound, and when there is a uniformly distributed load of 200 feet, so when you convert this uniformly distributed load into a point load, so it will act at the half length of the beam, and this will be equal to 200 over the length which it acts. So total length is 13 feet. So 200 multiplied by 13 will give you 2,600 pounds feet, and it will act at the half. So total is 13, so it will be 6.5 from either sides. So this is 6.5 feet. Now we'll apply equation of equilibrium in order to find this RA and RB. So what will be the equation of equilibrium? So first equation of equilibrium, that sum of all moments about point A is equal to 0, and taking the counterclockwise movement as positive. So about this point A, the first movement will be due to the 6 skips or 6,000 pound load, and perpendicular distance is 5, and this is producing clockwise movement, so it will be negative. So I will write minus 6,000 into 5. The second movement is due to this load, and this is 2,600, and the perpendicular distance is 6.5, and this is producing clockwise, so it will be also negative. So I can write it minus 2,600 multiplied by 6.5. And the last load which is producing movement about point A will be RB into perpendicular distance is 10 feet, and this is producing counterclockwise movement, so it will be positive. So I will write plus RB multiplied by 10, and the sum of all movement about point A must be equal to 0. So from here we will get minus 30,000 minus this will be 16900 plus 10 RB is equal to 0. So what we will get is that 10 RB will be equal to 46,900, and this RB will be equal to, if you divide 10 on both sides, so you will get 4690 pounds. So this is the value of RB, reaction force by bricks at point B on the beam or base plate. Now you can find RA by using equation of equilibrium, that sum of all forces along y direction must be equal to 0, and upward force is taken as positive. So RA is upward, so plus RA plus RB minus this 2,600 and minus 6,000, their sum must be equal to 0. So I can write RA plus RB minus 6,000 and minus 2,600 is equal to 0. So RA plus RB is 4690 minus 6,000 minus 2,600 is equal to 0. So when you calculate it, you will get RA will be equal to 3910 pounds. Now you have both RA and RB. So what we are going to do is that we will design this base plate. So what will be the parameters? So I will write the design must be based on the strength, and we will take the smallest strength, which is the strength of the pipe. So you have been given the allowable bearing stress of pine as well as for brick. So we will choose this value. Clear? This will be, and at point A, at A, first we will calculate for A. So at A we know that bearing stress is equal to bearing load over per unit area. So at point A you can see this load is offered on this bearing plate. Clear? So we will write it as RA divided by area of base plate at A. And the bearing, we have taken the strength of pine. So strength of pine is 2.81 ksi. So 2.81 into 10 to the power 3 is equal to RA, which is 3910. And area of base plate, if base plate is like this, the width is given. This width is 3 inch. Clear? And this length is not given. This length, which is length A. So I can write area will be equal to LA multiplied by 3. Clear? So from here you will get LA will be equal to 3910 divided by 2810 multiplied by 3. And when you calculate it, it will be equal to 0.464 inch. And if you can see that if length is one, we have been given that L should be 1 over nearest to 1 over 4 inch, which is equal to 0.5 inch. And if L is equal to half inch, it is 0.5. This is 0.25. Okay. As our value 0.4 is near to this 0.5, so L we use length of this base plate will be 1 over 2 inch. We can also write it 2 by 4 inch, which is again 1 over 2 inch. So length of this base plate is 1 over 2 inch. Now what we will do is that at point B, our base plate B, we know that stress is equal to RB divided by area. So from here the strength is 2.81 into 10 to the power 3 KSI. RB is calculated as 4690 divided by area of base plate for B will be LB into 3 inch. So again this length LB will be equal to 4960 divided by 2810 multiplied by 3. And when you calculate it, it will be equal to 0.556 since inch. So LB is equal to 0.556 inch. And we will take it nearest to 1 over 4 inch. So this is 1 over 4, this is 1 by 2, and 3 by 4 is 0.75. So our value is in between these two. So and for the closer, our safer design will be 3 over 4 inch. So we will choose LB is equal to 3 over 4 inch. 3 over 4 inch. Which is the answer of this question. So this length of this base plate should be half inch, clear, and this length of this base plate should be 3 or 4 inch. And that was all about this problem 1-85. I hope you have enjoyed this video and you have learned from it. Those who are new to my channel, then subscribe it, and don't forget to press the bell icon so that you can get notification about my latest videos. If you have any question, you can ask me in comment section. Thank you for watching and supporting me. Welcome back. In this video, we are going to solve problem 1-77 that is taken from chapter number 1, stress, and book name is Mechanics of Material by R.C. Hibbeler. So statement is the tension member is fastened together using 2 bolts, one on each side of the member as shown. Each bolt has a diameter of 0.3 inch. Determine the maximum load P that can be applied to the member if allowable shearing stress for bolt is 12 KSI and allowable normal stress is 20 KSI. So you can see this is member 1 and this is member 2 that are held together by using a joint having bolt on one on each this side and other one on the other side. And this is exerted by a tensile load P. So you have to find the maximum load or allowable load P that can be applied on this joint or on this tensile tension member. So let's start with the solution. So what will be the first step is that first step is if you cut this if you separate these members and draw the free body diagram, so it will be like this. Let me draw it first. This will be member. You can see this is a load P, clear, and this angle is 60 degree. So when you separate it, so you will be having a normal force perpendicular to this surface, clear, and this will act that we take it upward and there will be a shear force on this surface, clear. This will be a shear force. This is V and this will be equal to normal force. So we'll find this normal force and V in this member, because you can see that this normal force, this shear force will tend to shear this bolt and this normal force will cause the tension in this bolt. So based on these two criteria, we'll find the maximum load that can be applied on P. So we will find this equation, N and V by using equation of equilibrium. So first equation of equilibrium is that sum of all forces along Y direction must be equal to 0 and Y direction is taken in this, because you can see you have N in this direction and V is in this direction. So what we are going to do is if you draw a line parallel to this 60 degree, clear. So if you draw a line parallel to this 60 degree, so this P will have two components, one along this axis which is equal to one along this axis and other along this parallel to this N. So this will let this is equal to X component and this is equal to Y component. So you can see Px will be equal to P cos of 30 degree, P cos of 60 degree, clear, and this Py will be equal to P sine of 60 degree. And you can see when you apply this equation, so you can see the force in this direction is N and other force in this direction is Py, which is equal to P sine of 60. Their sum must be equal to 0. So I will write N minus Py, which is P sine of 60 degree, clear, is equal to 0. So from here, this N will be equal to P sine of 60 degree, clear, and this P will be equal to N divided by sine of 60 degree. So that will be equal to 1.1547 N times N, clear. So I will write it P will be equal to 1.547 times N. Let this is your equation number 1. Now we will apply another equation that sum of all component in X direction must be equal to 0 and force in this direction is taken as positive. So you can see V is in this direction and Px is in opposite direction. So plus V minus Px is equal to 0. So I will write V minus Px is equal to 0. So we know that Px is P cos of 60 degree, clear. So from here that is equal to 0. So V is equal to P cos of 60 degree, clear. And P will be equal to V divided by cos of 60 degree, and that will be equal to 2 times V. So I can write P is equal to 2V. That this is your equation number 2. Now you can see that here P is based on the normal force and here in 2 it is based on shear force. So what we are going to do is that we will first apply a criteria. We will apply criteria based on allowable shearing stress. Allowable shearing stress. So we know that allowable shearing stress is equal to V divided by area, since there are 2 bolts, one on this side and other one is on another side. So we will take this V. V is equal to V is V. We do not know V, so clear. I will write V divided by 2 bolts. So 2 multiplied by pi by 4 diameter of bolt is given as 0.3 inch, so I will write 0.3 square. And allowable shearing stress for bolt is 12 ksi, so I will write 12 into 10 to the power 3 is equal to V divided by 2. Will cut with this, so we will get pi by 2 into 0.3 square. And from here we will get V is equal to 12 multiplied by 10 to the power 3 multiplied by pi by 2 into 0.3 square. And you will get the shear force comes out to be 1.696 kip. Now you have this V, so put it in equation number 2. Put in equation 2. So you will get P is equal to 2 times V, and that is equal to 2 multiplied by 1.696 kip. So you will get this P will be equal to 3.39 kip. Now this is the tensile load based on, it is based on shear stress, allowable shearing stress. Now what we will do is that we will use, this was the first criteria, we will use second criteria based on allowable normal stress, and we know that allowable normal stress is equal to normal force divided by area. Since there are two bolts, so I will write n divided by 2 multiplied by pi by 4. Diameter of bolt is given as 0.3, so 0.3 square, and allowable normal stress is given as 20 ksi. So 20 into 10 to the power 3 is equal to n divided by pi by 2, 0.3 square. So you will get this n will be equal to 20 into 10 to the power 3 multiplied by pi by 2 into 0.3 square, and you will get this n will be equal to 2.827 kip. So put n is equal to 2.827 kip in equation number 1. And what is equation number 1? P is 1.547 times n. So P is equal to 1.547 multiplied by n. So 1.547 multiplied by 2.827 kips. You will get P is equal to 3.26 kip. And this P is based on, it is based on normal stress. There. So here you can see we have two values. One P is this one and another one is this one. So this largest load, I will write it over here. The largest tensile load, largest P which can be applied on this system is 3.26 kips, and which is the answer of our this question. Why we have selected this smaller one and called it as the largest load? Because you can see this load is less than this, so it will be safer. And if you put this P in this formula, and then shear force in this formula, so it will exceed the allowable, your shearing stress will be greater than this allowable shearing stress. So therefore for safer design we use P is equal to 3.26 kips. And that was all about this problem 1-77. I hope you have enjoyed this video and you have learned from it. Those who are new to my channel, then subscribe it, and don't forget to press the bell icon so that you can get notification about my latest videos. Also share my videos in your community so that my channel may grow further and most of the students may learn from my videos. If you have any question, you can ask me in comment section. Thank you for watching and supporting me. Welcome back. In this video, we are going to solve problem 1-24 that is taken from chapter number 1, stress, and book name is Mechanics of Material by R.C. Hibbeler. And the topic is internal loading. This is a complex problem. So statement is determine the resultant internal loading acting on the cross section of semicircular arc at C. So we have to find the internal loading at C, which means that we have to find the normal force, we have to find the shear force, and we have to find the movement. So I will write it. What we have to find is we have to find internal loading, which means the shear force, normal force, and movement. So let's start with the solution. So first step is that if I remove this pin support at point A, so there will be a reaction force in y direction, which is AY, and if you remove this, there will be horizontal reaction force. Similarly, there will be a vertical reaction force if we remove this roller support, so that will be equal to BY. So what we are going to find this BY, and then we will cut this arc beam over here, and we will take this area in order to find internal loading at point C, which is VM and N. Clear? So let's find it. Now what we will do, you can see that there is a angle theta is given, which is theta, and the radius arc is given, and there is a uniformly distributed load on this arc. Clear? So what we will do is that we will take a small differential area element. For example, that this is theta, so this angle will be equal to d theta. Clear? And this is the portion over which we are analyzing the force. So since this is distributed force, so when we convert this distributed force into a point force, so since this is differential force, so this differential force will be equal to this W naught times this arc length, which will be equal to r theta, because this is r and this is d theta, so it will be W naught r d theta. Clear? Now you can see that this force is acting perpendicular to it, so it is also making theta with the horizontal. Clear? And this will have two components, one along x direction, clear, and one along y direction. So we'll find these two components. So this is theta, so this component will be equal to W naught r d theta into cos of theta, and this component will be equal to W naught r d theta into sine of theta. And you can see distance from this to this is r. So again, if I draw a perpendicular line from this point, so you can see this distance is r. So this distance will become equal to r cos theta, because this is theta angle. So this is r cos of theta, and this remaining distance will be equal to r minus r cos of theta. So r minus r cos theta is actually, if you take r common, so it will be 1 minus cos of theta. Clear? Now we are ready to apply the equation of equilibrium. So first equation of equilibrium is that sum of all forces along sum of all movement about point A is equal to 0, and taking the counterclockwise movement as positive. So about point A, these two forces are not producing movement because they are passing through it. So first force which is producing movement about point A is By into perpendicular distance is 2r, because this distance is r and this is r, so it will be 2r, and this is producing counterclockwise movement, so it will be positive. So I will write By into into 2. So y should be on the lower side, on lower right side, by into 2. Now the second moment will produce due to this horizontal component, which is this one, and the perpendicular distance is this one. And this distance you can see, this since this is r, so and this is theta, so this component will be equal to r sine of theta. So this component multiplied by this component will give you the moment, and this will produce clockwise movement, so it will be negative. So I will write minus w naught r d theta into cos of theta multiplied by r sine theta. And you can see that this is differential force. So for taking the net force over entire curved beam, I will integrate it, so it will be integral of 0 to pi. Clear? And same is the case, the third force will be this df sine theta, which is w naught r d theta sine theta, and now perpendicular distance is this one, which is r into 1 minus cos theta, and it is also producing clockwise movement, so it will be negative. So I will write minus integral of 0 to pi w naught r d theta into sine theta multiplied by r into 1 minus cos of theta, and that is their sum of all moment about point A is equal to 0. So if you simplify it further, so by multiplied by 2, and that will be, you can see w naught into r, and r, these are constant, so we will take it out, so it will be equal to minus w naught r square and integral of 0 to pi cos theta into sine theta d theta. And same here, we will get w naught r into r is common, so w naught r square will be common, and we will left with 0 to pi, and it will be sine theta into 1 minus cos theta into d theta is equal to 0. Now further simplify it, by into 2 is equal to by into 2r, so you have to multiply it with r, by into 2r. So by into 2r minus w naught r square integral of 0 to pi sine theta into cos theta into d theta minus w naught r square, and we will have integral of 0 to pi sine theta into d theta minus integral of 0 to pi sine theta into cos theta d theta is equal to 0. Okay, so we will get by into 2r minus w naught r square into integral of 0 to pi sine of theta into cos of theta d theta minus this will be w naught r square integral of 0 to pi sine theta into d theta, and that will be plus w naught r square integral of 0 to pi sine theta into cos theta d theta is equal to 0. So you can see this will cancel with this, and we will left with by into 2r minus w naught r square integral of 0 to pi sine theta into d theta is equal to 0. And by into 2 minus w naught r square, clear, and that will give you integral of this sine theta will give you minus cos of theta from 0 to pi. So we will get, so this by into 2r minus w naught r square, and that will be minus cos of pi, minus will be plus cos of 0 degree is equal to 0. So by into 2r minus this will w naught r square, and this is 2, you can calculate it, this is 2. So by into 2r minus 2 w naught r square is equal to 0. So from here you will get by is equal to w naught into r. Now you have this by, clear. So what we will go is that we will section this beam at this point, and we will concentrate on this portion. So I have already taken this section. So what we will do is that you can see you have by is this one, which is by is equal to w naught into r. So when you cut it, so you will be having a normal force at point C, like this is nc. You will be having a shear force which is equal to vc, clear, and you will be having a moment which will be equal to mc, and this is the origin or center point O. So we will find this mc, nc, and vc. What we will do is again that you can take the differential, that this is the theta. So we will take a differential element, this will be equal to d theta. So this differential element will be having a differential force which will be perpendicular to this there, and this df will be equal to w naught r into d theta. And again you can see the total angle is theta, so this will also make, it will have two components, one is this one, another one is this one. So this component will be equal to w naught r d theta into cos of theta, and this will be equal to w naught r d theta into sine of theta. Okay, now we'll apply equation of equilibrium. So first equation of equilibrium is that sum of all forces along x direction must be equal to 0, and force in this direction is taken as positive. So you can see one force which is nc is in positive direction, and the other component of this force in this negative direction. There is no other horizontal force, their sum must be equal to 0. So I can write nc minus w naught r cos of theta into d theta. Since this is differential equation, so if I integrate from 0 to pi, clear, from 0 to pi by 2, sorry, pi by 2, so we will get a net force, horizontal force acting on the system. So I will integrate it from 0 to pi by 2. Okay, is equal to 0. So from here nc will be equal to integral of w naught r cos of theta into d theta, and 0 to pi by 2. It will be equal to w naught r integral of 0 to pi by 2 and cos theta into d theta. So when you calculate it, you will get 1 from this integral of pi by 2, integral of cos theta into d theta pi by 2, and you will get nc will be equal to w naught into r. Clear? Now we'll find this vc by using another equation of equilibrium, and that is sum of all forces along y direction must be equal to 0, and upward force is taken as positive. So you can see one force upward is w naught into r, the second force is vc, and the third force is this downward force. So minus w naught r sine of theta into d theta. And since this is differential force, so for entire length from 0 to pi by 2, we will get, if we integrate this force, we will get a net vertical force. So I will write integral of 0 to pi by 2 is equal to 0. Now w naught into r plus vc, and this is minus w naught r integral of 0 to pi by 2 sine of theta into d theta is equal to 0. And you will get 1 from this as well, so you will get W naught into R plus VC minus W naught into R is equal to 0. So from here, VC is equal to 0. It means that there is no shear force at point C. And the last thing is that we will find this moment NC. So what we will do is that we will apply equation that sum of all moment about point A is equal to 0, taking the counterclockwise moment as positive. Since this force is passing through point A, it is not producing moment, clear? And this force, net force, is also passing through point A, it is not producing moment. So only moment is produced by this By into perpendicular distance is R, and NC into perpendicular distance is R. So I will write NC into R, this is producing clockwise, clear? NC into R, this is clockwise, plus this By into perpendicular distance is R, and this is counterclockwise, so it will be plus. So By, which is W naught into R, and perpendicular distance is R, plus this MC, which minus MC, which is clockwise, minus MC. Their sum must be equal to 0. So NC is W naught into R, so it will be minus W naught R square, plus this will be W naught R square minus MC is equal to 0. So it means that moment at point C will be also equal to 0. So you can see we have found internal loading NC, VC, and MC at point C. Clear? And that was all about this a little bit complex problem 1-24. I hope you have enjoyed this video and you have learned from it. Those who are new to my channel, then subscribe it and don't forget to press the bell icon so that you can get notification about my latest videos. If you have any question, you can ask me in comment section. Thank you for watching me and supporting me. Welcome back. Problem 1-92. This problem is taken from chapter number 1, that is stress, and book name is Mechanics of Material by R.C. Hibbeler. So statement is, if allowable bearing stress for the material under the support at A and B is 1.5 megapascal, determine the maximum load P that can be applied to the beam. The bearing plates at A dash and B dash have square cross section of 150 by 150 millimeter and 250 millimeter by 250 millimeter respectively. So you can see this is the beam, clear, having support A and B, and there is a bearing plate A dash and B dash at this support. There is a uniformly distributed load over length of 1.5 meter, and the cross sectional area of A dash is 150 by 150 millimeter, and at B it is 250 by 250 millimeter. So you have to find the greatest load or maximum load that can be applied on this beam. So let's start with the solution. So what will be the first step? The first step is that if you remove this support at point A, so you will be having a reaction force. Let this reaction force is NA, that is offered by the support on the beam. And if you remove this support at B, so it will offer a vertical reaction force on this beam, and let this will be NB. So we'll find this NA and NB by using equation of equilibrium. So what will be the equation of equilibrium? So first equation of equilibrium is that sum of all moment about point A is equal to 0, and taking the counterclockwise moment as positive. So you can see here there is a uniformly distributed load. So when converted into a point load, so it will be 40 multiplied by the length over which it acts, and it will act at a distance half of this length, which is 1.5 divided by 2 is 0.75 meter. So first we will convert this uniformly distributed load into point load, so it will be equal to 40 multiplied by the length over which it acts, and the unit will be kilonewton, and that will act at half of this 1.5. So this distance will be 0.75 meter. Okay, now we apply equation of equilibrium about point A, sum of all moment about point A. So first moment about point A is due to this NA, and perpendicular distance is 3 meter, and this is producing counterclockwise moment, so it will be positive. So I will write NB multiplied by 3 meter. The second moment that is produced due to this uniformly distributed load, when converted into point load, it will be this one, and perpendicular distance is 0.75, and it is also producing counterclockwise moment, so it will be positive. So I will write 40 multiplied by 1.5, and the perpendicular distance is 0.75. The last moment that is produced due to this P load, and perpendicular distance will be 4.5, and this is producing clockwise movement, so it will be negative. So I can write minus P times 4.5 is equal to 0. So from here you will get 3NB. The second term will give you plus 45, and minus 4.5 times P is equal to 0. So 3NB is equal to 4.5 times P minus 45. And if you divide 3 on both sides, so you will get NB will be equal to 1.5 P minus 15. Clear? So this is the vertical reaction force of the support B on the beam. Clear? Now we'll find this reaction force at point A. So for that I will apply another equation of equilibrium, that sum of all moment about point B is equal to 0, and taking the counterclockwise moment as positive. So first moment will be due to this force, and now perpendicular distance is this one, which is 3.75, and it is producing counterclockwise moment, so it will be positive. So I will write 40 multiplied by 1.5, and perpendicular distance is 3.75. The second moment about point B is due to this NA, and perpendicular distance is 3 meter, and this is producing clockwise moment, so it will be negative. So I will write minus 3 times NA, and the last moment is due to this P load, and perpendicular distance is 1.5, and this is producing clockwise movement, so it will be also negative. So I will write minus P times 1.5 is equal to 0. So what we will get here is the first term will give you 225 minus 3NA minus 1.5 times P is equal to 0. So 3NA will be equal to 225 minus 1.5 times P. And again, if you divide 3 on both sides, so you will get NA will be equal to 75 minus 0.5 times P. And this is the vertical reaction offered by support A on the beam. Now we have these two beams, so according to Newton law, the same load will be transferred to this bearing plate here at point A and at point B. So what we will calculate, we will calculate the P load for plate A. We will calculate P load for plate at A dash. We know that allowable bearing stress at plate A, let me correct it, this is allowable bearing stress at plate A will be equal to normal load A divided by the bearing area of A dash. Clear? So we have normal load is 75 minus 0.5 times P. Area of bearing plate is given in meter. It is 0.150 multiplied by 0.150. Clear? And we know that allowable bearing stress for this material is given as 1.5 megapascal. So I will write 1.5 into 10 to the power 6 is equal to 75 minus 0.5 times P divided by 0.150 multiplied by 0.150. Okay, so what we will get is that 1.5 multiplied by 10 to the power 6 multiplied by 0.150 whole square is equal to 75 minus 0.5 times P. So 0.5 times P will be equal to 75 minus this whole term, which is 1.5 into 10 to the power 6 multiplied by 0.150 square. And if you divide 0.5 on both sides, so you will get P will be equal to 75 minus 1.5 into 10 to the power 6 multiplied by 0.150 square divide by 0.5. And after calculation, you will get P will be equal to 82.5 kilonewton. Now this is the load that will be acting on the beam, and that will be there for plate at A dash. What we are going to do is that we will find P load for plate at B dash. That will be equal to bearing, allowable bearing stress will be equal to normal load at bearing plate B divided by area of bearing plates. So normal load at B is 1.5 times P minus 15. Since this load is in kilonewton, let me check it. This load is in kilonewton, so this unit will be also kilonewton. Here, and I forget to put 10 to the power 3 to convert it into newton. So you have to multiply 10 to the power 3, and again this will be equal to divide by 10 to the power 3. Clear? And here you will also have 0.5 divided by 10 to the power. You can see, here also it is divided by 10 to the power 3 and 0.5 into 10 to the power 3. So you will get, so kindly make this correction 0. Here 10 to the power 3 to convert it into newton. And area of this bearing plate at B is 0.250 square meter. And 250 multiplied by 0.250. And allowable bearing stress is 1.5 megapascal. So 1.5 into 10 to the power 6 is equal to 1.5 times P minus 15 into 10 to the power 3 divided by 0.250 square. So from here you will get 1.5 multiplied by 10 to the power 6 multiplied by 0.250 square divided by 1000. Our 10 to the power 3 will be equal to 1.5 times P minus 15. So what we will get is that 1.5 times P is equal to 1.5 into 10 to the power 6 multiplied by 0.250 square divided by 1000 plus 15 is this one. If you divide 1.5 on both sides, so you will get the value of P, which will be 72.5 kilonewton. And this is the value of load that is applied to the beam and that this plate B can bear. Clear? So we have to choose one value. So we will choose one value of P. So choose that is maximum load that can be applied on the beam. That will be 72.5 kilonewton, which will be the answer of this question. Now, most of students ask why you choose the smallest, because in question it is given that choose the largest. So this load is safer. So if you apply this load, this beam will, the load in plate B will be less than 82.5. But if you apply this load, so it will this P will be greater than the sigma B allowable bearing stress in plate B will be greater than the given allowable stress. That's why we choose the smallest one. And that was all about this problem 1-92. I hope you have enjoyed this video and you have learned from it. Those who are new to my channel, then subscribe it and don't forget to press the bell icon so that you can get notification about my latest videos. If you have any question, you can ask me in comment section. Thank you for watching. Welcome back. In this video, we are going to solve problem 1-88 that is taken from chapter number 1, stress, and book name is Mechanics of Material by R.C. Hibbeler. So statement is the compound wooden beam is connected together by bolt at B, assuming that connection A, B, C, and D exert only vertical forces on the beam. Determine the required diameter of bolt at B and the required outer diameter of its washer. If allowable tensile stress for the bolt is 150 megapascal and allowable bearing stress for the wood is 28 megapascal. Assume the hole in the washer has the same diameter as the bolt. So you can see these are compound beams that are connected together by a bolt at B, and this reaction at A, B, C, and D only exert vertical force. All other loadings are shown over here. Clear? So you have to determine the diameter of this bolt. Clear? Diameter of this bolt and the washer that is used, outer diameter of the washer that is used in this bolt. So let's start with the solution. So as this is a compound beam, so what we will do is that we will first draw the free body diagram FBD of member or beam CD. So you can see this is beam CD. So there is a vertical reaction force of D at D, which will be FD. There is this load, this load. Now the bolt will exert a load that will acting downward on this, and this reaction force by the C will be upward. So we will draw its free body diagram. So let me draw it first. Let this is the beam. Here you have to draw it. This is point C. So we have FC that will acting upward. This is C point. This is your D point here. So your force D will be also upward. FD. There is a 2 kilonewton load acting at a distance of 1.5 meter from this. So this distance is 1.5 meter. There is another load which is also 1.5 kilonewton and acting at a distance of 1.5 meter from the 2 kilonewton load. Now this is point B. Clear? So the load that is acted upon by this, the bolt acts on this member or beam CD is FB. The distance between FC and FB is also 1.5 meter, and from B till this node is also 1.5 meter. Now we'll apply equation of equilibrium in order to find this FB and FC. So what actually we are interested to find out this load FB. So what we are going to do is that we will apply equation of equilibrium that sum of all moment about point D is equal to 0 and taking the counterclockwise moment as positive. So first moment about point D will be equal to this force FB, and perpendicular distance is this, sum of all this is 4.5 meter, and this is producing counterclockwise moment, so it will be positive. So I will write FB into 4.5. The second moment that is produced due to this 1.5 kilonewton load and the perpendicular distance is 3 clear meter, and this is also producing counterclockwise moment, so it will be positive. So I will write plus 1.5 into 3. The third load which is producing moment is this 2 kilonewton and perpendicular distance is 1.5 about point D, and it is producing counterclockwise moment, so it will be positive. So plus 2 into 1.5. And the last force which is producing moment about point D is FC, and this whole perpendicular distance is 6. This distance is 6 meter, and this is producing clockwise moment, so it will be negative. It will be negative. So I will write minus FC multiplied by 6 is equal to 0. So from here, this will be equal to 4.5 times FB minus 6 times FC, and these two terms, this and this term will give you minus plus 7.5. When move toward right side, it will be minus 7.5. that this is your equation number 1. Now what we will do is we will take the free body diagram of this beam AB. So you can see there is a vertical reaction force. The C will now act downward on this, and FB will be also upward on this, and there is a load. So we will draw this free body diagram. So I will write free FBD of member AB. So let me draw the free body diagram again. So you can see this is point A. So you will be having a vertical reaction force, which is FA. There is a 2 kilonewton load, 3 kilonewton load. You can see this is 3 kilonewton load that is acting at a distance of 2 meters from this side. Let this is point C, clear? So at C you will be having a force that will be acting downward. Why? Because you can see that this force at C will be upward. So as there is Newton third law, it will be acting downward. So this is FC, clear? And same FB here is downward, clear? So here it will be upward. So let this point is your point B. So here it will be upward, FB, clear? And all the distance between these two forces are 2 meter, clear? And from C to B it is 1.5 meter. Now we will apply equation of equilibrium. So the equation of equilibrium which we will apply is sum of all movement about point A is equal to 0, and taking the counterclockwise movement as positive. So about point A, one movement that is produced due to this FB and perpendicular distance is 2 plus 2 plus 1.5 is 5.5, and this is producing counterclockwise movement, so it will be positive. So I will write FB into 5.5. Clear? The second movement that is produced due to this FC and perpendicular distance is 4. This is 2 and this is 2. So it will be 4 meter, and it is producing clockwise movement, so it will be negative. So I will write minus FC multiplied by 4. The third moment will be produced due to 3 kilonewton load and perpendicular distance is 2, and this is producing clockwise, so it will be also negative. So I will write minus 3 into 2, and the sum of all moment about point A must be equal to 0. So what we will get is 5.5 times FB minus 4 FC is equal to 6. So from here you will get 4 FC is equal to 5.5 times FB minus 6. And if you divide 4 on both sides, so you will get 5.5 divided by 4 FB minus 6 divided by 4. And that will give you 5.5 divided by 4 will give you 1.375 times FB, and 6 divided by 4 is 1.5. And this is your equation number 2. Now what we will do is that put equation 2 in equation number 1, which is this one. You can see, so 4.5 times FB minus 6 times FC is 1.375 FB minus 1.5 is equal to minus 7.5. So 4.5 FB minus 6 multiplied by 1.375 is 8.25 times FB plus 6 multiplied by 1.5 is 9 is equal to minus 7.5. Clear? So minus 4.5 minus 8.25 FB is minus 3.75 FB is equal to minus 7.5 minus 9, which is equal to minus 16.5. And if you divide minus 3.75 on both sides, so you will get FB is equal to 4.4 kilonewton. So this is the force in the bolt. Now what we will do is that put FB in equation number 2. So you will get FC will be equal to 1.375 times FB is 4.4 minus 1.5, and you will get FC will be equal to 4.55 kilonewton. Okay, since we are in need of force in this bolt, so now we will calculate the diameter of this bolt. So what actually I will write is we have been given allowable stress for this bolt is given as, which is equal to FB divided by area of bolt. So FB is 4.4 kilonewtons, so 4.4 into 10 to the power 3. Area of bolt is pi by 4, diameter of bolt square. Clear? So allowable stress for the bolt is 28 megapascal. So I can write it 28 into 10 to the power 6 is equal to 4.4 multiplied by 10 to the power 3 divided by pi by 4 dB square. So from here you will get dB square is equal to 4.4 multiplied by 10 to the power 3 divided by pi by 4 into 28 10 to the power 6. And if you take square root on both sides, so you will get the diameter of bolt will be equal to it will be 0.00611 meter. Our diameter of bolt will be equal to 6.11 millimeter. So this is the answer of our first part. Now we'll move towards second part, and in second part we have been asked to find the outer diameter of washer. So for washer, so you can see if this is a circular washer, clear, the inside diameter will be diameter of bolt, so this will be dB, and we will need diameter of washer, outer diameter. Clear? This is dW. So bearing stress, you can see that this washer is in contact with this wooden piece, so bearing pressure will be there. So this allowable bearing stress for this wooden will be equal to FB divided by area of washer. Clear? So FB is 4.4 kilonewtons, so 4.4 into 10 to the power 3, and area of washer is pi by 4 dW square minus dV square. So diameter of bolt in meter is 0.00611, so 0.00611 square. And allowable stress for the wood is 28 megapascal. Okay, so 28 megapascal. So 28 into 10 to the power 6 is equal to 4.4 into 10 to the power 3 divided by pi by 4 into dW square minus 0.00611 square. So when you calculate it, dW, you can now find it, dW square will be, or dW, when you calculate it, it will be equal to 0.0154 meter, or that will be 15.4 millimeter. Also make a correction that here allowable tensile stress for the bolt is 150 megapascal. So I will write it as 150 megapascal. Correct it, 150 megapascal. So 150, here this will be also 150, and you will get this diameter of bolt. So make this correction, and that was all about this problem 1-88. I hope you have enjoyed this video and you have learned from it. Those who are new to my channel, then subscribe it, and don't forget to press the bell icon so that you can get notification about my latest videos. If you have any question, you can ask me in comment section. Thank you for watching. Welcome back. In this video, we are going to solve problem 1-89 that is taken from chapter number 1, stress, and book name is Mechanics of Material by R.C. Hibbeler. So statement is determine the required minimum thickness T of the member AB and edge distance B of the frame if P is 9 kips and the factor of safety against failure is 2. The wood has a normal failure stress 6 ksi and shear failure stress of 1.5 ksi. So you can see this is the member AB and the thickness is not known. We have to find this thickness and this B distance, the load acting or this frame is P, which is 9 kips. The normal failure stress is 6 ksi and shear failure stress is 1.5 ksi. So you have to determine this thickness T and this B of the frame. So let's start with the solution. So first we will find internal loading. So let me write it first. The normal force developed in member AB can be determined by considering the equilibrium at joint A. So what we will do is that we will take this joint A and we will draw the free body diagram and we will find the force AB. So let me take this. This is let member AB and this is member AC. Yeah. Okay. So this is member AC and this is member AB. This is B. This is your point A and this is your point C. At A we have vertical load of P, which is given as 9 kips. So 9 kip. So when you cut it, section B, so you'll be having a reaction force acting on section AB. Let this force is FAB, and when you cut it, you will be having a normal force, a normal axial force, which will be equal to FAC. Now, if I take a horizontal line from this, so it will be let this will be your x-axis, and this will be your vertical will be your y-axis. And you can see here this makes an angle of 30 degree. So again, if I draw a horizontal line, so this will be also 30 degree. So it's called alternate angle. So this angle will be 30 degree. Here, this angle is also 30 degree. Now, if I take the center line of this member and this member, so we will apply equation of equilibrium in order to find the FAB and FAC. So this FAB will have two components. This FAB will have two components, one along x-axis and other along y-axis. Clear? So we will apply equation of equilibrium that sum of all forces along x direction must be equal to 0 and upward force is taken as positive. So you can see this force will have one component. This FAB is like this. So it will have one component this and other. So horizontal component will be equal to FAB cos of 30 degree. And since it is toward positive side, so I will write it FAB cos of 30 degree. And same is the case, this FAC will have two components. One is this one, another one is this one. And this component is FAC cos of 30 degree. And it is toward negative direction. So I will write minus FAC cos of 30 degree. And their sum must be equal to 0. So it means that FAB cos of 30 degree is equal to FAC cos of 30 degree. So cos of 30 will cancel each other. So FAB will become equal to FAC. Okay, now we'll apply another equation of equilibrium, that is sum of all forces along y direction must be equal to 0 and upward force is taken as positive. So you can see one force which is downward is minus 9. So I will write minus 9. This component, the vertical component of this force, which was FAB sine of 30 degree is upward, and similarly FAC sine of 30 degree is also upward. Their sum must be equal to 0. So plus FAB sine of 30 degree plus FAC sine of 30 degree is equal to 0. Now you can see FAC is equal to FAB, so I will replace this FAC with FAB. So it will be FAB sine of 30 degree plus FAB sine of 30 degree minus 9. So 2 times FAB sine of 30 degree is equal to 9. And when you divide it, FAB will be equal to 9 divided by 2 sine of 30 degree. So you will get FAB will be equal to 9 kip. Clear? So let me write it. FAB is equal to FAC is equal to 9 kip. Now we have this force in member AB and AC. So what we are going to do is that you can see that this member is over here. So due to this force FAB, it will be having two components, one along x-axis, y-axis, and another along x-axis. So this force will cause the shearing in this region. So we'll find that. So let me draw its free body diagram. So I will write if I take that portion, or if I take the member AB and joint B using joint B of member AB. So this is joint B. Clear? So you can see you will be having this FAB in this direction. FAB will be like this. This is FAB. So it will be having two components. One is this one and other one is this one. Clear? This is angle 30 degree. So this component will be equal to FAB cos of 30 degree, and this component will be FAB sine of 30 degree. So we'll find this FAB cos 30. So what I'm going to say is that this is the member AB. Clear? And this was the joint like this. This is the member. So force in this member was 9 kip. And it will having two components. This is 30 degree. Clear? And this is your point B. So at point B, you can check it that it will have a reaction force in horizontal as well as in vertical direction. So I will write this horizontal component will be FBX and the vertical component will be FBY. Now what we are going to do is that we will find this FBX and FBY by using equation of equilibrium. So first equation of equilibrium is that sum of all forces along x direction must be equal to 0, and force in this direction is taken as positive. So you can see we will need only this horizontal reaction force because it is creating shear at this point, clear, at this point. So we'll find this by using equation of equilibrium which I have written. So FBX minus the horizontal component of this, which is 9 cos of 30 degree. So I will write it minus 9 cos of 30 degree is equal to 0. So from here FBX component will be equal to 7.794 K. Now this horizontal force is actually, you can see it will exert by this member over here. As a result, this member, this force, horizontal force, will produce shear in this area. So if I draw a free body diagram of that portion, so that this is the portion where you have a net force of FBX is applied, and due to that we have a shear V which is taken as VA-A. What is A-A? So let me show you that if you take this line, so this is the plane AA where you cut it, and we have drawn the free body diagram over here. Okay, so FBX is 7.794 kips. So by using equation of equilibrium, sum of all forces along x direction must be equal to 0, and force in this direction is positive. So VAA minus 7.794 is equal to 0. So VAA means shear force, horizontal shear force, will be also equal to 7.794 kip. Now you have both this normal force in member AB and shear force. So what we are going to do is that we will find allowable stresses. So let me write it: allowable normal stress and shear stress. How we'll find that? We have been given this normal failure stress and shear stress. We also know the factor of safety. So using these values, we will first calculate allowable shearing stress. So allowable normal stress. So allowable normal stress is equal to failure stress divided by factor of safety. Clear? So failure stress is 6 and factor of safety is 2. So it means that allowable normal stress is 3 KSI. And same is allowable shear stress is equal to failing shear stress divided by factor of safety. So failing shearing stress is 1.5 divided by 2 is 0.75 KSI. So now we will use these two to find the force in AB, and we will find the distance B. So first we know that allowable normal stress is in member AB is FAB divided by area of AB, that is equal to 3 into 10 to the power 3, and FAB is 9 KSI. So I will write it 9 into 10 to the power 3. Now what is area of AB? So you can see the thickness is this one, which is not known, and the width is 3. So it's actually T by 3 inch. So we will use this area is 3 multiplied by T. Clear? So from here you will get T will be equal to 9 into 10 to the power 3 divided by 3 into 3 multiplied by 3, which is equal to 1 inch. So this is the answer of our first part. Now we'll find this tar allowable is given as VAA divided by area of AA. So let me show you. You can see here shear stress is VAA, and the area is this B, clear, and the area is B multiplied by this thickness. You can see this is 3. Sorry, this is the length B, and this is the width 3 inch, and this will be the shearing area. So it will be 3B. So put the values. VAA is 7.794 divided by 3B is equal to allowable shearing stress, which is 0.75 into 10 to the power 3. So what we will get is that B is equal to 7.794, and there is 10 to the power 3 because K is pound kip. So 10 to the power 3 divided by 3 into 0.75 into 10 to the power 3. So what you will get is B is equal to 3.46 inch. So that is the answer of our second part. So I will conclude that this thickness T is equal to 1 inch, and this B is equal to 3.46 inch, which is the answer of this question. And that was all about this problem 1-89. I hope you have enjoyed this video and you have learned from it. Those who are new to my channel, then subscribe it, and don't forget to press the bell icon so that you can get notification about my latest videos. If you have any question, you can ask me in comment section. Thank you for watching and supporting me. Welcome back. In this video, we are going to solve problem 1-93, that is taken from chapter number 1, stress, and book name is Mechanics of Material by R.C. Hibbeler. So statement is the rod AB and CD are made of steel. Determine their smallest diameter so that they can support the dead load shown. The beam is assumed to be pin connected at A and C. Use LRFD method where the resistance factor for steel in tension is 0.9 and the dead load factor is 1.4. The failure stress is 345 megapascal. So you can see this is beam AC that is supported by two rod AB and CD that are made of steel. The dead load is shown over here. So you have these are the pins supported at point A and C. So using load and resistance factor design method. So you have to calculate the diameter of rod AB and this diameter of rod CD. So let's start with the solution. So you can see that due to this dead load there will be a tensile stress in rod AB and CD. As a result, this rod exert a vertical force FAB on this beam and FCD on this beam. Clear? So we'll find this FA and FCD by using equation of equilibrium. So it is better to draw a separate free body diagram for saving time. I am already drawing over here. So this is FAB, which is the force that is exerted by this rod on this beam, and this is FAC. So we'll find this FA and FAB and FAC by using equation of equilibrium. So first equation of equilibrium is that sum of all moment about point A is equal to 0, taking the counterclockwise moment as positive. So about point A, the first force which is producing moment is FAC, and perpendicular distance is 3 plus 3 plus 2 plus 2, which is 10. And this is producing counterclockwise moment, so it will be positive. So I will write FAC multiplied by 10. The second moment which is produced by this 5 kilonewton load and perpendicular distance is this 7 meter, and this is producing clockwise, so it will be negative. So I will write minus 5 into 7. The third load which is producing movement is 6 into perpendicular distance is 4 meter, and this is producing clockwise, so it will be negative. So I will write minus 6 into 4. And the last force which is producing movement about point A is 4 into perpendicular distance is 2, and this is producing clockwise, so it will be negative. So minus 4 into 2 is equal to 0. So we will get 10 FAC is equal to 67.67 kilo Newton. And from here, this FAC will be equal to 6.70 kilo Newton. Now this is FAC, so we can find FAB by using another equation of equilibrium is that sum of all movement about point C is equal to 0, and taking the counterclockwise movement. So you can see that about point C first movement is FAB and perpendicular distance is 10. This is producing clockwise movement, so it will be negative. So I will write minus FAB into 10 clear. The second movement will be 4 into perpendicular distance is this 8, and this is producing counterclockwise movement, so it will be positive. So I will write 4 into 8. This force is producing 6 multiplied by 6, and that is counterclockwise, so it will be positive. So I will write plus 6 multiplied by 6, and the last force is 5 into perpendicular distance is 3, and this is also counterclockwise, and the sum of all moment about point C is equal to 0. Okay, so from here when you calculate it, you will get FAB is equal to 8.30 kilo Newton. You can also find this by using this equation that sum of all forces in y direction must be equal to 0, and upward force is taken as positive. So FAB minus 4 kilonewton minus 6 minus 5 plus 6.70 is equal to 0. So FAB is equal to minus 15 plus 6.70 is equal to 0. So FAB will be equal to 8.30 kilonewton. So you can use any of this in order to find this, but this one is the simplest one. Now we have FAB and FAC. We have been given as vectored load. So we will find vector load because you can see that we have been given dead load factor is 1.4. So this load FAB will be increased by 1.4 times. So 1.4 multiplied by FAB is 8.30. So this load will be increased. So it will be equal to 11.62 kilonewton. And similarly, FAC will be also increased by 1.4 because the dead load factor is given. So we have to multiply it. So this will be equal to 9.38 kilonewton. Now using LRFD, load and resistance factor design method. Clear? By using this, we know that this factor which is given as pi 0.9. So this 0.9 into 0.9. 0.9 into failure will be equal to for rod or for rod AB. 0.9 into failure will be equal to FAB because this is in tensile. This is given resistance factor for steel in tension is 0.9. So this will be equal to area of AB. Clear? Now what we will do is that from here 0.9 failure stress is given as 345 megapascal. So multiply by 345 into 10 to the power 6. Clear? Is equal to FAB. FAB is 11.62 and 10 to the power 3 will convert it into Newton divided by area. So pi by 4 DAB square. Clear? So what we are going to calculate is we are going to calculate DAB. So DAB square is equal to 11.62 into 10 to the power 3 divided by 0.9 into 345 multiplied by 10 to the power 6 multiplied by pi by 4. And if you take square root on both sides, so you will get DAB will be equal to 0.00690 meter, or DAB will be equal to 6.90 millimeter. So this is the diameter of rod AB. Now for rod AC, we will get 0.9 multiplied by failure is equal to FAC divided by area AC. So definitely you will get this will be equal to FAC divided by area AC, which is pi by 4 DAC square. So from here you will get DAC square will be equal to FAC divided by 0.9 multiplied by failure stress into pi by 4. And taking the square root on both sides will give you FAC is 9.38. So 9.38 into kilo. So 10 to the power 3 divided by 0.9. Failure stress is 345 megapascal. So 345 into 10 to the power 6 pascal and pi by 4. So from here this DAC will be equal to 0.00620 meter, or this DAC will be equal to 6.20 millimeter, which is the diameter of rod AC. So this is diameter of rod AB and this is diameter of rod AC. And that was all about this problem 1-93. I hope you have enjoyed this video and you have learned from it. Those who are new to my channel, then subscribe it and don't forget to press the bell icon so that you can get notifications about my latest videos. If you have any question, you can ask me in comment section. Thank you for watching and supporting me.